Okay, so here's the whole model. And this might look complicated, but you have to have faith that it really isn't as complicated as it seems. Okay, so first of all, we have that population just grows exogenously. This is also going to be the workforce. So this is very simple. You start with some level of population today. Tomorrow you have 1 plus n times that many people. And those people are also the number of workers that you have. As we said, savings is just a constant fraction s of income. And therefore, since savings plus consumption equals income, we can then say that, find that consumption equals income minus savings, and that's just going to be equal to 1 minus S times Y. All right? So the consumption decision here is not being made optimally. People just have a rule of thumb that says, I want to consume some fixed fraction, 1 minus S, of my income. Now, what does production depend on? Well, now this looks just like our production function from before, except that we now have little t subscripts on these variables. So the capital stock, which is available to be used to produce goods today, comes from past investments. And then N is just the labor force, which, as we see, is growing exogenously. And this is just a particular kind of constant returns to scale production function, where you raise these things to this power alpha and 1 minus alpha. Equation 5 is how capital accumulates over time. So the capital stock that you have for producing goods next period depends on 1 minus delta times the capital stock that you had today. So this is just the undepreciated capital, plus the new purchases of capital, which is investment. So equilibrium is going to be Y is equal to C consumption plus savings, but that's also equal to consumption plus investment, or to word it differently, the savings that consumers do goes directly into the firm's investment and therefore produces new capital in the future. Now, because we look at growth rates or economic growth in per capita terms, we want to divide all of these variables by population, by N. And what we'll do is we'll use lowercase letters to denote the per capita values of these variables. Okay, so in per capita terms, here's the model. We have that the growth rate of population is just 1 plus N. Per capita consumption is 1 minus S times per capita GDP. Per capita savings is per capita GDP minus per capita consumption, or S times per capita income. Production income is Z times K over N. We've divided everything by N, remember? So now we have a production function that's a little simpler. We basically don't have to look at what's happening to N. We just have that per capita GDP equals technology times per capita capital stock. And then this just gives us what happens, how this is also called the law of motion for capital, but this tells you how capital gets accumulated over time. It's going to depend both on, because this is in per capita terms, it's going to depend on the growth rate of the population, and it's going to depend on the depreciation rate. And then the equilibrium condition is very simple. It's just all of this stuff in lowercase instead of uppercase. So now let's talk about how the model is going to work. Equations 9 and 12 tell us that a fraction S of goods that are available every period is going to be saved. That savings automatically becomes investment. 1 minus that savings rate is the fraction of goods that are available today that are going to be consumed. Now, by equation 11, everything that gets saved becomes, by equation 12, everything that gets saved becomes investment. That investment then contributes to the capital stock that you'll have next period. But then once you have that capital next period, KT plus 1 is going to tell you how much you can produce next period. And then you start all over again. Savings at T plus 1 is just going to be some fraction S times the goods available. That becomes investment at time T plus 1, which then becomes capital stock at period T plus 2, and so forth. So that's how the model is going to work. And what we will do is solve this model and see what happens to economic growth as various things change.